Hey everyone, in today's video, we're going to see about MLOps and how it works in the backend. We have few automations like Airflow, GitHub Actions, Kubeflow, and all. You can explore that. But here I'm going to show step by step what are the files that we need to write in order to have this entire flow to be working. So first, let's start with data pipeline. So data pipeline, which is going to be our data fetching and validating, and it does the feature engineering, everything it does. And finally, it exports the train and test split to the model. So this is a normal thing that we do in machine learning. What we do is we fetch the data and we clean the data, pre-processing it basically, and later we validate it by a lot of metrics and a few checks that we do with a data, whether it is actually suitable for the model that we put in. We balance the data and we do feature engineering in order to extract the most important metrics or columns that we need to use for the training purpose. Because with this thing, we can eliminate the garbage data, because when garbage in, it comes out with a garbage. So we need to exclude those things because we are going to automate this entire process. So we can't just go and sit and do each and everything, right? So for that, we need to have these things before building a prediction model. So first, I'm just writing a function to load the data. Here, I'm just collecting the California housing data, which is default, constant one, and a fancy one because we don't have any flaws in it. It is there. For the demo purpose, I just included this particular data. You can write your own metrics for data. So if you're using your domain specific data, you have to be very particular about pre-processing. Only you know like what your data is about. So I'm just taking raw data as a California housing price, which is available online. So validation, I'm just removing all the null values in it, balancing the data. If I'm having any NAN, I'm just replacing it with a maximum number of occurrence. So these things I'm just including in the pre-processing. Right? Later, I'm just doing a feature engineering with a taking average and searching for any common variables in it, standard deviations, and with the mean and median. I'm just exploring those things with a basically, I'm just taking an average price of it so that with the entire columns that I'm extracting, which is distributed properly, just exploring that. It is not like having much of an engineering correlation, covariance, and all, but with only those information like average, because the data is so perfect and I don't need to have any other engineering or extracting techniques. And later I'm just splitting the data into 80 and 20 default split. I'm just saving it as an Excel, CSV files here. You can see the split in here. So it's just that I'm having this numeric value. It is going to be a regression model, of course. So we have all this data split. So next what we're going to do is train the model. So we did all the pre-processing here in data pipeline. And next I'm just going to train the model. So with the training function. So here I'm just going to use three models. One is random forest, gradient boosting, and linear regression. Linear regression is one default model for California housing price because it is everywhere and the data is perfect and we can go with it immediately. But I just wanted to explore few other good working model also, so that the flow will pick what would be the best. We'll go in later part. So this is a packages that I've installed for all these three models commonly, so that I won't get any drawback or backpress. So just that. We are installing a lot of packages, new packages like gradient boosting regression, which I didn't have. I have given in requirements, so we can explore that also. So MLflow is one package that I installed because we are going to use MLflow for this entire automation. And yeah, other things which will be there. So the dependencies and all, we can go with that. So here MLflow config, because we're just going to orchestrate everything inside MLflow package. And one is random forest, gradient boosting, and linear regression. Just give all the parameters inside what it need to have, the learning rate and all. So give that number of estimators. You need to give. You don't have to give like epochs and all, but just give the learning rate so that we can, in general, we can have the number of epochs, estimators count, and maximum depth of the tree. For linear regression, we don't have anything. We don't need anything parameters. So just that. And the data, input data, and evaluation metrics. I'm using RMSE and MAE and R square. I just give the formula for that. It is like MCP. We write protocols, right? Same thing. We just give everything predefined and what it need to have. Everything you have to give specifically it in depth, so that it continuously do. Why I'm saying I have to write everything and test it. Just run and see the program or program file that you write, because if it stops in between, we won't know where it stopped and which part is not working. So it is okay to have an alert also. That is a different thing. For a big pipeline, like entirely structured pipeline, you should have an alert. But here I didn't include any alert, but it is good to have. So here are the uh, visualization I just mentioned, like how it is going to give the final results. We can see visually what all the things that it learned and unlearned. So this is a training metric, sorry, a training file. And next, we need to do the flow, how it actually work. We need to test it, and that's all. So next, we'll see the register model. Register model function is after doing the training from these three algorithm, it finalize with one model which gives a best accuracy. So register is basically it is going to register and assign it as a champion because it gave a good accuracy and with the perfect metric of results that we get. So with that, it proceeds with other predictions. So for that register model file, I just wrote. So this is one. And next is API server. The server is to connect your model, and we can just call and serve it in through API, so that we can test the entire application. So this is like test API just wrote. And last is monitor. Monitor, why is because I didn't know that this is very important, because at one point the price of an house would be increased or decreased. So the price or any parameters or any other feature or columns would have been updated. Any variable would have been updated in future times. For that, we need these kind of monitoring, because it will say there is a change in something. It won't completely tell you that what have changed, but it alert you that there have been some changes in the data or in any versions that it is working with an algorithm. So it says that there is a problem. So it is kind of alert, but it says like there is a problem in the data, or we have to mention like where it need to be actually monitoring, whether through the data or parameters or algorithm norms. So those things we need to specify. With that, it tells you that there is a drift. With that, we can just say and go and find the exact location where it is actually having a problem, and we can sort the drift and make it working again. So for that, I just included monitor. Now let's see how it is actually running. So you can run MLflow in two ways. I am using SQLite because I'm using DB for it. So I'm just using this particular thing. It is good to have a virtual environment always. So, so this is our data where we can see these are like different kind of algorithm that we particularly have. And if you want to see any column running, that also we can see. So gradient boosting, okay, gradient boosting is, yeah, these are parameters. So if you want to see any, I mean, metrics in any, for any of the algorithms, you can add those. And parameters also we can see. So just included those things in here, like with what it learned and all. For linear regression, we didn't, for gradient boost, we just gave like 0.1. Random forest, it's a tree-based algorithm, right? So it does by its own. So these are these things. So let's see another way of uh, so we're going to explore what have been registered as a champion. Champion in the sense like which one is performing well. Yeah. So version 3 model of gradient boosting, which have 83 percentage of R square value with this particular data that have been finalized as champion. So the best model is we have gradient boosting compared to other things which have like less accuracy, I mean R square value, and we have 84, around 84 we have for gradient boosting. So that is how this thing have been finalized. And you can also see like how it actually finalized as a champion. So we have a server running now. Okay. So you need to initiate the server first. Then you can see the prediction. I mean, the test cases that I've wrote in the test underscore API. So here it is. Sorry. Yeah. You can see like how it is actually going to function with a few inputs and what would be the output as in from the champion model that we have, no, like gradient boosting. So all API test cases have been passed and we have a prediction with very high income area and predicted with a particular price. So this is how you can test it with a few of the inputs. And at last, we need to get a monitoring, like how it is actually monitorable. See. So I've installed all the packages through my virtual environment. So whenever I'm just doing it, just initiating the virtual environment, you also do the same. Okay, so we have reports of what is working, what is not working. Yes, so there is a drift. Yes, in medical income, these are the features that we have selected and gave house age. So we have a drift in these things. It may be a update in the value, or there are lack of information in this features. So this is how it monitors and tells us like uh, there is a problem in data and we need to rectify it somehow. So for that, we need to come with certain measures for that. So first, I just started with this MLflow, and here is my server initiation, and this is my API call for the testing using the server in the backend. And at last, I'm just testing it with a monitor. So whatever you do, it is there, and you can easily see some of the values like how it is actually worked behind in MLflow. Just explore MLflow. It has a lot of features, and we can use so many things in it. And also, you can explore some of the automation which is available, like Kubeflow is best. So try that. Airflow or GitHub Action is also okay. So try that. It is very important if you are someone who's going to continue your career in machine learning and AI. So I hope this video finds you well. That's all I have for today. Thanks for watching. Bye.